Okay, I am back, and I made a little bit of a mistake here. Well, we're going to go to n minus r plus 1, right? Because if we went to n minus r, then we'd have picked r plus 1 people, right? Because you think about it, you start a list at 1, you don't start at 0, right? So yeah, so that's n minus r plus 1, right? And yeah, so this goes to n minus r plus 1. I'll just add a little plus 1 there. So it's going to be n factorial over, well, what are we canceling out of n factorial? N times n minus 1 times n minus 2, all the way up to 3 times 2 times 1, right? What do we need to cancel so that we get to n minus r plus 1? Well, let's think what's after that in the factorial. Well, it's going to be, we're going to subtract 1 from this to get to the next one, right? So the 1's cancel. So n minus r. n minus r minus 1, n minus r minus 2, all the way up to 3 times 2 times 1. That's what we need to cancel out of this n factorial, right? So that we get from n to n minus r plus 1. So we're canceling this. You might notice that this is equal to n minus r factorial, right? Because you're subtracting 1 from all the n minus r. So then we're going to need to divide by n minus r factorial to cancel it. This is the formula for permutation. Pretty interesting. So that's permutation, but that's not combination, because in combinations order does not matter. So there's a couple of ways I can explain it to you. I'm going to teach you another trick while I'm at it. So let's say down here that I want to arrange the words in give me a word. Let's say Chinggis. Chinggis, right? How many ways are there for me to do this? Well, it's well, there's what, 1, 2, 3, 4, 5, 6, 7. 7 ways for me to do the first one. 6 ways for me to do the second one, because if I've used one, then I can't use it again. 5 ways. 4 ways, 3 ways, 2 ways, 1 way. 7 factorial, right? Right? Yes. And so if I have any letter word, as long as there's no repeating letters, it's going to be the number of letters in the word factorial, right? Let's say I want to arrange the number of letters in cool, right? You think it's 4 factorial. However, let's think about this, right? If one of our arrangements is OCOL, right? If I flip these two O's around, it's not going to change anything. It's still going to be OCOL. However, I've flipped them, and this is counted twice. OCOL is counted twice, right? Because when it flips them, you know, the factorial doesn't know that these are both the same letter when you're doing 4 factorial. So what you've got to think is, for each time, every time that I have an arrangement, let's say loco, all right? For each time that I have an arrangement, how many ways are there for me to arrange the letters that are same? We want to divide by this, right? Because loco is considered the same. Let's call this one O1, this one O2, right? That's equal to LO2CO1, right? For us, however, not for the factorial, because they're considered as different. That's why we need to divide by the number of ways we can arrange them, right? Because you can have this guy here or this guy here. So we need to divide by 2 factorial, right? Or 2, right? Because there's 2 things, and we need to find how many ways we can arrange them. So obviously we divide by 2 factorial. This is equal to 12. Now let's do a different one. Let's do Bobby. So we have 5 factorial once again. Now we have 3 b's, right? Let's say one of our things is y, o, nope, that's a bad idea. Y, b, b, o, b. b1, b2, b3, right? This is equal to y, b, b, o, b, which this is b2, b1, b3, or b1, b3, b2, or b1, b3, b2, b1, 2, 1, 2, 3, or 2, 3, 1. 6 ways. Well, there's going to be 6 ways to do it when there are 3 letters. How about when there's 4 letters? How about let's just add another b, right? Y, b1, b2, 0, b3, b4, right? How many ways? Well, there's going to be 4 factorial, right? Because I need to arrange these 4 b's in a way, right? This b can go there, 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 or here. So there's 4 ways for b1 to go. For b2, b1's already taken one of the positions, so there's 3 ways for him to go. b3, 2 positions. b1, b4, however, there's 1 position. 4 factorial. Think about it with 5. It's going to be the same thing. So we're going to do 5 factorial over, in this case, 1, 2, 3. So 3 factorial, which just so happens to be 20. Let's do one more. What is sounds really bad. Oh God. I'm trying to think of a letter that has like, multiple repetition. Oh no. Give me a second. Let me plug in my phone into this charger. We'll think about this. Why can I not think of one? Oh God. Sure. Why not? We're doing 17. It's the first thing I saw with multiple. S E V E N T E N. 1, 2, 3, 4, 5, 6, 7, 8, 9. Over. Well, let's see. We have 4 V's. Are we done? No, because we have 2 N's. So now we have to think, right? We have to think. For each of the ways that the 4 V's are arranged, there's also 2 ways for the N's to be arranged with each of the 4 V's. So this is also going to have to be included in this, right? That was kind of a confusing explanation, but you kind of get the gist, right? 2 ways to organize N for each arrangement, 2 factorial ways to organize N for each arrangement. And yeah, and then 4 factorial ways to organize E. We do 17s, then we're going to have another 2 factorial for the S. You get the gist, right? And so that's pretty useful. There's a lot of like letter combination stuff in that. So hopefully this makes sense so far. It's quite long. Now, let's combine these two to do choosing, right? 1, 2, 3, 4, 5, 6 people choosing to bam bam, right? At the same time. Bam, bam. How many ways? Well, let's think. It's kind of like permutation, so let's start there, right? So 6 choose 2. 6 factorial over 6 minus 2 factorial, which is 4 factorial. This is a permutation. This is a way to choose one guy, then the next. Now let's think, right? We have 1, 2, 3, 4, 5, 6. I know I'm drawing the same diagram. Let's say I'm picking these two, right? In a permutation, I'd pick this guy, then this guy, or this guy, then this guy, right? And that counts as 2 ways. However, when you're choosing both of them at the same time, right? So we're going to want to divide by 2 factorial, right? in the number of ways to arrange the way that I pick the guys, in a permutation at least, right? So essentially, if I'm picking two people, right? I'm picking these two people, right? For permutation, there's two ways to do it. For combination, there's one way, right? You pick these two at the same time. Permutation, this guy, then this guy. Let's do, this guy and this guy, right? Two ways to pick them in a permutation, one way in a combination. We're going to divide by the number of ways that we can order the way that we pick them, because that's not relevant in this case. It's because order doesn't matter. That's a saying. That's something you'll hear a lot in combinations and in counting with restrictions. Order does not matter. I'm going to divide by 2 factorial in this case. This computes to be 15. Now let's go on to the biggie. The reason why we're here. N choose R. I have N people. I need to choose R. Let's start with our same permutation case. N factorial over N minus R factorial. Now let's think here. We have N people, right? We are picking R of them. In a permutation, those R people can be arranged in how many ways? Well, this is quite simple. It's the same, right? We have R people. How many ways can we arrange them? Well, 4 people. You have 4 factorial ways. 5 people. 5 factorial ways. R people. R factorial ways. Right? That's why in a permutation we don't divide by R factorial, because that's what we want remaining is R people. We're not going to divide by R factorial because that's the number of ways that we can arrange the people within this. Why would we divide by it? We still need it. However, when you're choosing something, the order does not matter. You're choosing them all at the same time, right? Order doesn't matter. So if we include the R factorial ways to arrange, picking 3 people out of 5, if we include that, we're going to have, 6 factorial times as many ways as we would with a combination. Well, not 6 factorial, but you get the point, right? Like the order doesn't matter, therefore the number of ways that we can order those people by picking them in a certain order will not matter either. So we're going to divide by R factorial, right? Because that's the number of ways that we can order the picking of those people. And this is our formula. Hopefully it made sense. If it didn't, ask why. So, what have we learned today? Let's write down all our things, right? N permutation R is equal to N factorial over N minus R factorial, right? If you are arranging letters, right? How can I write this one? Let's do, the number of ways to arrange this is how we'd write it. Is you have how about A sub 1 A R B, oh no, not 1. You start at 0, right? A sub 0, A1, A2, AR. I'm just trying to think of a way to write this. B0, B1. And A0 is a non-existent, so it's not there. Up to BR all the way up to Z sub R is equal to, how can we write the number of letters? I'll just write n for the number of letters factorial over, how do we write the number of repeats? God. Oh, these all need to be different letters, right? A sub A. No, God. Okay, B sub B, C sub Z, right? And they're lowercase this time. So we need to do A factorial, B factorial. This is kind of a confusing way to write it. I'm just trying to think of a cool way to write it. I'll probably post a formula in the comments for this one, but the number of ways to arrange a word is going to be the number of letters in the word. Okay, let's write this. Okay, number of letters in the word factorial over number of repeats factorial per letter. 1 factorial is equal to 1. So if there's 1 repeat, then you're not going to have anything. This was counting with box. Very important episode. Oh God. Let me write the choose one as well. And choose r is equal to n factorial over n minus r times r factorial. There we go. Counting with box. Hope you enjoyed. Leave questions, thoughts, comments, hopes, and dreams. Colleges down below. Goooooooogon. Let's end at 17 minutes. Hello, everyone. It is me, back at it again. We're trying to go a bit fast here. However, let's begin today. We are doing counting probability tips and tricks, specifically counting. And today we're going to be learning about combinatorics, combinations and permutations, and letter arrangements. All kind of similar, and I will show you how. This might seem, yeah, okay, let's begin. So we're trying to find, essentially, the value of 6, choose 2. Essentially, if I have 6 things, and I'm choosing 2 of them at the same time, what is this equal to? And also, if we have n things, we're choosing r of them, what is that equal to? That's our essential question. If you're choosing something, then it's written as this. So n things choose r. It's written as that. That's what we're trying to find, right? Let's begin with something simpler. Permutations, right? So what is a permutation? Well, let's say I have 6 things, and I have to choose 2 of them, but they're not at the same time. So I choose one thing, then the other. Let's think about this. How can I find the number of ways I can do that? Well, there's 6 people, right? So there's 6 ways I can choose the first one. And then when that, let's say it's this person, when he's gone, there's 5 ways for me to choose the next one. And that's going to be true for all of it. So that's what's going to be 6, how we write permutation 2. Right? And now let's try and generalize permutations. So, how can we do this? Well, let's say we have n things, and we're permutation r, right? How can we generalize this? Well, let's think. How many ways are there for me to pick the first one? Well, there's n ways, and times n minus 1 ways, times n minus 2, and so forth, until we get to how far? N minus r, but then plus 1, because we already started with the n, right? So think about it, right? You're going to, so let's take if we multiply this by -1, this becomes 1 minus n, and 2 minus n, right? So then we have a list up to, what is that? R minus 1 minus n, right? If we ignore the n, take out the n, right? 1, 2, up to r minus 1, right? And So obviously there's going to be r minus 1 terms in that. However, we want r terms, right? So, but then we also have the n. So that's why n minus r plus 1 will work and not n minus r. So we go to n minus r plus 1. Now let's find how we can generalize this. Well, let's start with something simple. Let's start with n times n minus 1 all the way up to 3 times 2 times 1. So it's decreasing. And this we write as n factorial. So 2 factorial equals 2 times 1. 3 factorial equals 3 times 2 times 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, which is 720. Okay. Anyways, so we start with n factorial, right? But then we need to remove the terms up to how far? Well, this is n minus r plus 1. So then what would the next term be in n factorial? Well, it would be n minus r, right? And n minus r minus 1 all the way up to 1, right? So how can we format this? Because we want to divide by this, right? N factorial by this so that we get what we want. Well, this is just n minus r factorial, right? Because you're subtracting 1 until you get to 1. So it's n factorial, and then we divide by n minus r factorial. And this is the general form for permutations. So this is how you can calculate any permutation if it's asking for you to, like, you know, Johnny picks without replacement 1 marble, 3 marbles from a pile of 6. Well, you're going to have 6 factorial over 6 minus 3 factorial. So 6 factorial over, in this case, 3 factorial would get us to, what would that be? 120, right? And so yeah, that's cool. It's going to be a bit different in the next part where it cuts because the video got deleted for some reason. So yeah, goodbye. Well, not really. Yeah, it'll just cut off and stuff. I'll say I'm back, and then I'll say I made a mistake, but I didn't actually. In this case, I made a mistake in the past video.